Virtual local area networks. Now, interestingly, whenever I ask someone what are VLANs, they scratch their heads answering it, and even after that, they are not correct. But in this video, we will solve every doubt one can get regarding VLANs. So let's get started. Let's see how a simple local area network works. We have couple of switches, routers, PCs, and they communicate locally with each other with the help of these devices. Now we all know how router works. We have static routes, dynamic routes, based on which it takes decision of forwarding the data between different networks. Now let's dive deep about switch where VLANs actually operate. Switches have separate collision domains on each port, and because of that multiple devices can send traffic at once without any collision, or in simple words without any accident. But wait, all the ports in the switches are in the same broadcast domain, meaning that if a message is broadcasted, it will be sent out to every port present on that switch. So to quickly summarize, switches have separate collision domain for each port and all ports in the switches are in the same broadcast domain. So the thing is, when we send a message to a device for the first time in the network, the switch does not know where to send it because it does not have any physical address stored for that device. And hence what it does is broadcast that message. So it floods out that message to every port on that device because all are in same broadcast domain. But let's just say that we grow as a company, cause we always do, and add one more department and add one more device in the first department, a new joinee or something like that. And now someone wants to communicate with that device. And when this happens, the switch does not know where to send the message. And hence, it will broadcast it in its broadcast domain. And that's where problem arises. See, now a different department with different network mask will also have to process this broadcast traffic, which leads to higher utilization and wastage of bandwidth. And this is where VLANs became a messiah. Let's discuss the golden rule of VLANs. Communication between devices can only happen if they are both in same VLAN, meaning that if device A belongs to VLAN 3, it can only communicate with the devices in VLAN 3. If VLANs does not match, the traffic is dropped at the switch level. Other than that, VLANs have two types of ports, access ports and trunk ports. Keeping it simple, access ports are configured on ports connecting end devices such as PC, server, etc. Trunk ports are configured on ports connecting to other network devices like switches, routers, etc. So trunk ports does VLAN tagging to notify the other network device that this is the VLAN the device sending the message belongs to. And this is how VLAN saves bandwidth by limiting the propagation of broadcast message. Let's discuss the benefits of VLAN. So the primary reason, the main reason is limiting the scope of broadcast message to improve network efficiency. In a way, we are creating separate broadcast domains in a switch. Other than that, security. It provides security because as we saw, broadcast message got sent to other department. Despite of different network mask, it bypassed the router. Restrictions. So with the help of access control list ACL, we can control which VLAN can communicate with which VLAN. If you want to see how it is configured, the link is in the description. Please check it out. Now let's get into the CLI to understand VLANs from the code. So let's just take a switch here and let's see what are the VLANs, configurations of VLANs currently made in this switch. Let's just see that. The command to check information about VLANs is show VLAN. See. Now notice here there is already a VLAN made which is VLAN 1 named default, and all the ports in this switch are currently under VLAN 1. So if you want to check, we can check it like show IP interface brief. See, all the ports that are in this VLANs in this switch is currently under VLAN 1 with name default. What we learned basically is that Switch sends unknown traffic into its broadcast domain. So this is that broadcast domain. VLAN 1 is that broadcast domain. Because all the ports are under VLAN 1, so it will send message, the broadcast message to all the ports because there is no other VLAN configured. These are the VLAN configured here, but they don't have any ports. This is the only VLAN which does have these ports. And this is the broadcast domain I was talking about. Now, what we will do is let's just create a basic topology here to understand the principles. And we have to assign an IP address. 192. I don't know why am I assigning gateway. So currently they are both in the same network mask. Now if we connect this, they should be able to send message to each other right now. Let's just wait for this to be configured. Yeah, they are configured now. So let's just send this. Yeah, they are both successful. Okay. Now what we will do, we will create separate VLANs. We will create different VLANs. So what we will do is we will create different VLANs and assign these ports to them. We are breaking this broadcast domain into different broadcast domains. We are creating different broadcast domains in a similar switch, in a same switch. So for that, let's just create a VLAN. To create that, you have to, of course, go to the global config mode and write your VLAN 2. Any number you can give if you want to show up to how many, if you want to see how up to how many. 1 to 4094. Do not use VLAN 1 because it's already configured in the switch. So just VLAN 2 and name admin. Exit from here. VLAN 3, name general. We are basically naming this VLANs because it's easier to understand. After that, now see, PC0 is connected with switch from the port fast Ethernet 01 and PC2 is connected with the switch from the port fast Ethernet 0/2. So what we will do is configure these ports as access ports. Why access ports? Because these are end devices. These are not networking devices. PCs are considered as end devices. So what we'll do is interface fast Ethernet 0/1 and switch port mode access. Now here enter, and we have made this access, but which VLAN to access? We will have to specify which VLAN should this port access. Should this port be able to access? So what we will write is switch port access. We have made it as an access port, but now which VLAN to access? We want it to access VLAN 2. Sorry, we have to write VLAN keyword and VLAN 2. And after that, exit from here. Now we want fast Ethernet 02 to be configured accessing VLAN 3. So interface of fast Ethernet 0/2 and switch port mode access and switch port access VLAN 3. Right? After this is done, you can see it is right now being configured properly. Let's just wait for it. Yeah, so it has been configured now. Now, if you want to send, it should not be able to ping each other. It should not be able to send message to each other. And this is what happens. What we did is, let's just again see show VLAN. See, there was this default VLAN, all the ports were there. What we did, we created VLAN 2 admin, VLAN 3 general. We provided fast Ethernet 01 with VLAN 2 and 02 with VLAN 3. And because they are both in a separate broadcast domain, in different broadcast domain, they won't be able to send message to each other. This is the golden rule, that VLANs, that the devices in separate VLANs won't be able to send message to each other. And that is it for today. I hope you all understand the concept of VLANs. Check the video in the description for inter-VLAN routing. If you learned something from the video, like it. If you want your friends to know about it, share this video. And if you have any doubts or any views regarding the video, bad or good, comment it. See you in the next video. Till then, disconnecting.